We're going to do a bunch of examples of finding domains for radical functions, like this first one that I've got here, and rational functions, which would be a fraction of polynomials. Let's go ahead and start with the radical functions. So in this one, I've got the square root of x minus 2. Well, the thing to remember is that anything inside of a square root, actually any even root, can't be negative. If it was negative, it would not be a real number. So I'm going to take what we've got inside there, that radicand, but what's inside, and I'm going to set it greater than or equal to 0. And then x, if I bring the 2 over by adding it, I get x is greater than or equal to 2. Now on a number line, it would be greater than or equal to, it'd be an closed circle and then 2 here, but I really want to express these using interval notation. If I'm including the 2, I'm going to use a square bracket. So 2 is the lowest number in this domain, and it goes up forever, so infinity is the highest number. Now you could verify this with a graph. The square root starts right there at 2 and then continues on forever like this. Let's do another couple of radicals before we get to those rational functions. So for this one, I have another square root, which means that I do have a domain restriction, and I need to make sure that what I've got inside the square root is greater than or equal to 0. So I say 3 minus 2x needs to be greater than or equal to 0. Now, a couple different ways that you could solve this. I'm going to move the 3 to the other side by subtracting it. So I get negative 2x is greater than or equal to negative 3, but then I also need to divide by a negative, which is an opposite. So as I'm dividing by the negative, I've got to swap that sign as well. So I end up with 2x. I'm swapping my sign because of the division by the negative is now less than or equal to 3. So a little bit to watch out for. Divide both sides by 2, and x is less than or equal to 3/2. If I put this on a number line, let's say that 3/2 lives right here. I do want that to be or equal to, and then everything less than or equal to. So my domain as an interval would be, let's see, negative infinity. It goes on forever to the left. So negative infinity is going to represent that lowest number. We always use parentheses for our infinities. And then 3/2 is my uppermost number, and that is included, so I do a square bracket. Here comes the next one. So in this one, I've got a cube root. The domain restriction only happens if you have an even root, a square root, a fourth root, a 28th root, but it doesn't happen with these odd roots. So for example, if you were computing the cube root of negative 8, it gives you a real number back. Negative 2 cubed is negative 8. So when it comes to a cube root or any odd root, super easy. There are no domain restrictions, so my domain is all real numbers. So you can write that as a capital R with 2 bars, or let's just run the entire number line, negative infinity to positive infinity. Let's get into those rational functions next, those fractions of polynomials. For the first rational function, I want to look at just good old 1 over x. Well, whenever I've got a fraction of polynomials, I run the risk of dividing by 0. For this one, I cannot have a 0 in the denominator, so x cannot equal 0. Actually, whatever the denominator is can't equal 0. To express the domain here, I want to think about that number line. So on the number line, I can take everything except for 0. So I'd have an open circle here, and then everything on either side. Let's put this into interval notation. So this is going to go down to negative infinity. That's my lowest number. And then it's going to come up to 0, but not quite hit it. So up to 0, parenthesis. And then I've got another set I need to join this with. So I'm going to join this with a union. I'm going to start on the other side of 0, and then 0 to infinity. So really what this says right here is my domain is everything except for 0. Negative infinity to infinity, but we're going to skip right over 0. Let's do another one that's similar to this one. So let's say that we've got f of x is equal to 3x plus 2 divided by x minus 5. So I'm just going to take that denominator and I'm going to say that that denominator cannot equal 0. X minus 5 cannot equal 0, which means that x cannot equal, if I add a 5 to both sides, cannot equal 5. So I will take everything except 4. I'm going to put an open circle there at 5. Everything to the left, everything to the right. So I'm starting really with negative infinity to infinity, but I need to skip over 5. So my domain is negative infinity to, I'm going to come up to 5, then skip it. Union with, I'm going to start on the other side of 5 and continue on my number line with everything else up to infinity. So this is my domain. Sometimes we're going to need to factor the denominators to figure out where they're equal to 0. I give myself a little bit more room here, and let's look at one where we need to do some factoring. Say I've got f of x is equal to, let's do x plus 4 divided by x squared minus 16. Now x squared minus 16 is a difference of squares, but I'm going to go ahead and just take this denominator and say that x squared minus 16 cannot equal 0. I can factor this difference of squares, x plus 4, x minus 4. What makes this 0? Let's see, if x was equal to a negative 4, that would make this first factor 0. If x was equal to a positive 4, that would make the second factor 0. So I know that I want to throw out both the negative 4 and the positive 4. So we want all the x's except for positive or negative 4. Now, if you were tempted to cancel with the x plus 4 in the numerator, don't cancel with the numerator. We want to know in its original form what won't work in that denominator, and certainly a plus or minus 4 is going to make that denominator 0. So what does this look like as an interval? Well, I know that I need to leave out negative 4 and positive 4. So I need to start at negative infinity, go up to negative 4 but skip it, then continue on, skip 4, and continue on. So as I write this as an interval, it's going to be negative infinity to negative 4. I'm not including that, so parenthesis, union, that takes care of the first section. The middle section now is going to be between negative 4 and 4, so negative 4 to 4, and then union 4 to infinity. Okay, let's do one more. In this next one, I have both a square root and I've got a polynomial in my denominator. I've got two domain restrictions. My final domain are going to be all the x's that work for everybody. I don't want to make the denominator 0, and I want to make sure that inside that square root is either positive or 0. Let's go ahead and start with the radicand. What's inside that square root? So x plus 1 needs to be greater than or equal to 0. If I subtract the 1 from both sides, x needs to be greater than or equal to negative 1. This starts off my domain. So whatever I end up including, it can only be greater than or equal to negative 1. So here's negative 1. I'm going to include that, and then everything greater than or equal. Let's see if we get any additional domain restrictions from the denominator, and we do. So we want to make sure that x minus 7 is not equal to 0. If I add the 7 to both sides, or you can just look at this one, x cannot be 7. So that's an extra domain restriction. So if I find 7 over here, I need to create an open circle. So what can I include? I can include negative 1 to 7, but I need to skip over 7, and then I can include everything else on the other side of 7 up to infinity. So my answer is going to look like this. Square bracket, negative 1, comma, 7. I'm not including 7. That takes care of the first piece. The second piece, I'm going to join that with my union symbol. Starts on the other side of 7. So 7 comma, and then everything else that goes all the way to infinity. So that's going to be comma infinity. And this is our domain. I hope this was helpful. Take a look at the description below for more videos and watch this next one. It's really going to help you out. Thanks for watching.